Hello and welcome. In this video, we're going to talk about the decision control logic applied using if, elif, and else. In general, a Python code would get executed in sequence line after line. But there could be specific reasons for us to alter this sequence based on a particular condition being satisfied or not satisfied. And that's what essentially is controlled using if, elif, and else. This comes quite handy when you're writing your own functions or you're trying to build some logic around a data. But to begin with, we'll start at a very basic level. We'll take very simple examples to ensure that you get proper understanding of how all these work. If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Also, after watching this video, you may want to refer to some of the playlists that we have created for people who are interested in in-depth knowledge. These are the videos in the right sequence, which will give you thorough knowledge of the subject. Please share it with all others who might benefit. Let's get started. So we are looking at a Google Collaboratory notebook, and we will first begin by talking about the if statement. So let's say we have a number, which is 20. That's something which we're giving as an input. And we are trying to check if this number is actually greater than 10. So we will write a condition like this. If the number is greater than 10, then we want to print a statement which is number is greater than 10. Very basic condition. So the general format for if statement is that followed by if, you'll have a condition that evaluates to true or false. If this condition evaluates to true, then the if block is executed. Now, if you've learned programming using other languages, you would know generally the blocks are represented using curly brackets. But in Python, this indentation tells Python that this is a code block. So indentation is nothing but a kind of space that you've given from the left. We started if right from here where we could type the first alphabet, but here we've given a space. Now, does it have to be fixed? Does it have to be just one space or two spaces? So the standard is that they use 4 spaces or a tab. But even if you use less spaces, let's say we just type one space here and we execute it, would it work? It works. The standard practice is that we use 4 spaces. So I'll bring it back here and I press a tab on my keyboard. This gives 4 spaces. This is a standard. And if we run this, it works again. So this indentation tells that we are entering a specific block. Generally, whenever you have this colon symbol that you see here, it indicates that there is a block that's following next. And this indentation further affirms that there is a block that's next. So a single if is checking for a condition, and if the condition is found to be true, it's printing an output. Now, if we write something after this, let's say we write something but without indentation, how would that be treated? Let's say we try to print, it will print anyway. Let's say this is something that we have typed. Would this have a connection with this if? The answer is no. Irrespective of whether the condition here is true or not, this line, the last line that we have entered, will be printed. Let me run this for you. See, now if let's say we enter a number which is less than 10, we enter a number which is 7 and we run this. So now what will happen is this number is 7. Obviously, it doesn't satisfy this condition. It is not greater than 10. So the block within if should not be executed, but this line will still be executed because based on indentation, this does not come under the if statement. Let me run this for you. It'll print anyway, right? Now let's understand what does it look like visually in terms of flow. So a single if is like this. We have an if condition and we check if the condition is true. Then we execute the block and it ends. Now let's introduce else as well. First of all, if and else have to be mutually exclusive. What does it mean? They can't be overlapping. It cannot be both if and else satisfied at the same time. It cannot have conditions like that. First of all, else itself would not state any condition. So it only works on one condition that's given by if. If this condition is true, then this first line will be executed. If it is not true, then the else block will be executed. Once again, we are performing the same check. We're passing a number. We're checking if it's greater than 10. This is the condition. 7 is not greater than 10. We know that. So what happens is it will not execute the if block. It'll come to the else block and it'll print the outcome, which is the number is not greater than 10. Let's just run this. The number is not greater than 10. Now you may be wondering, why are we even introducing else? We could have written if twice. Could we do it like this also? For example, if we write, if number is greater than 10, I want to print this. If number is less than or equal to 10, which means it is not greater than 10, then we will do this. We could do it like this also, and this is not wrong. In this case also, it's going to give us the same output. But there's a fundamental difference between how these two work. And that's what I'll try to explain you through the flowchart. So here's what is happening. When we use if with else, we check for the condition. Condition only comes with if. We check for the condition. If it's true, the if block is executed. If the condition is false, then we go to the else block and execute it, and the execution ends. But When you're using if twice, this is what is happening. You have two separate if conditions to check, and you are checking the condition twice. Now, it may not matter for this simple an example that we are talking about, but imagine if you're working on a large code and you're making your computer evaluate the conditions multiple times unnecessarily, that will be an extra workload. So efficiency-wise, this is a better way rather than using two if conditions wherever it is feasible. Now let's understand the elif. Elif is in short written for else if. So elif can be another condition check. How does it work? Let's say we have to look at the outcome, which depends on number of conditions. For example, we will check if the number is greater than 0. We will print the number is positive. We will check if the number is less than 0. We'll print the number is negative. And the number can also be 0. So we will have to have an else option here, which says the number is 0. Now, these three distinct outputs cannot be given using if-else alone. And that's why we are relying on elif. If you see, if has a condition, elif has a condition, but else again does not have a condition. So once again, if we execute this, what do you expect as an output? If we give the input as number 7, of course, the first condition itself is satisfied. So we can run this. We expect the output that the number is positive. But if we change this to, let's say, a -3, and we run this, it's supposed to print the number is negative. That's it. And if we change this to 0 and we run this, it should come to the else block and it should say the number is 0. Now, there is no limitation to how many elifs you can use. We can use a sequence of elifs. It works with the same logic. Also note one more thing. An if can work alone, and that's where we started. We said we want to just check if a number is greater than 10, and we could do our work there. But we cannot work with an else alone. So if you remove if here and you want to execute only else, that would not have a meaning. It already is giving an error. If you see, collaboratory is pointing out. So else does not exist without if. If can exist alone as well. Similarly, elif would always follow after an if. It will not be written before an if. Only when if is not true is when we come to elif. And the last choice will be else. Else can also be eliminated here. So if we don't want to check this, let's say we ignore the third possibility of the number being 0, we can remove this and it would not lead to any error. This is totally fine. So let me show you how the flow chart for if, elif, and else looks like. So it would check for two conditions. It'll check for condition belonging to if block. If the condition is satisfied, then it executes that if block and that's the end of it. If not, then it goes to the elif condition because elif can also have conditions. If that condition is satisfied, then it executes the elif block. But if that is again false, then it goes to else as the last choice. So this is the visual representation of if, elif block. Now, if you have multiple elifs there with you, you can just imagine this kind of piece here. This entire piece would be extended multiple times. And finally, you can have an else. That's again an optional thing. You may or may not use else all the time, but if elif would be needed if you have multiple possibilities that you're looking. We also can perform nesting of the if-else conditions. So let's say we are checking if the number is positive, and then within that, we are checking if the number is even or odd. Otherwise, we are leaving the number as negative or 0. So if you see the condition here, and that's where the indentation becomes important. If the number is positive, only then within that block, we are checking if the number is even or odd. So we have an if-else inside an if statement, and then we have a separate elif. This would be matching with this if. So if the number is greater than 0, that's not true. Then where would we go? We'd not go inside this block. We'll be straight away coming to this elif, which will check if the number is less than 0. And if both of these don't hold good, then it'll proceed to else. So that's the nested if-else condition for us. Let's say we give an input, which is 10. Obviously, when it's 10, it is going to enter this block, and it's going to check if 10 is divisible by 2. So when you say a number modulo 2, this actually checks for the remainder. So this is a double equal to sign. It's not an assignment. It's an equality check. If the number that you entered divided by 2 results into a remainder, which is 0, it prints that the number is even and positive. Else it prints that the number is positive because it's greater than 0, but it's an odd number. Let's run this. So it'll enter this block and says number is positive and even. Let's say we change this number to 9. We expect this to enter here. Number is still greater than 0, but it doesn't satisfy this condition. So it will take the else block here within this earlier if block. It says number is positive and odd. And if we change this number to -9, it'll straight away skip this if right from here because the first condition itself is not satisfied. It doesn't enter this block. It straight away comes to elif, finds this condition is true. It'll print that the number is negative. That's why this is called a control flow, because it allows you to hop from one place to another rather than executing the entire piece in sequence. So together with if and else, we can also use logical operators like and or, and these are essentially applied between Boolean conditions. So if you have an outcome that's resulting into a true or false, we can apply logical operators. Let's just see how we apply it. So let's say we have two numbers, x and y, and we are trying to check if x is greater than 5 and y is less than 8. So x is a separate variable. Is it greater than 5 in this case? If you're giving the input as 11, yes, it is. Is y less than 8? It's 7, so it's less than 8. And would result into a true only if both the conditions are satisfied. So each of these, if you see, are Boolean conditions. This results into a true, and this also results into a true. If both are resulting into a true, only then this overall condition is true. And you know if is executed only if after this if statement, you get a true condition. So if this is true, it'll print that both the conditions are true. Or on the other hand, is slightly different. Or will check for at least one of the conditions being true. If any one of the conditions would be satisfied, or will be executed. So is x greater than 12? It's not true. Is y less than 3? It's again not true. So both the conditions here are not satisfied. In that case, it will not execute this outcome. Let's run this. It executes the first one, right? But if we make some changes here, let's say we make this as 2. Now what do you expect? As per the first condition, x is greater than 5. Yes, x is 11. That's greater than 5. Y is less than 8. That's again true. So both the conditions are true. This should be executed. What about this? X is greater than 12? No. But is y less than 3? Y is less than 3. So this is also true. Let's see what happens now. Both the options are printed. And this can also be tried for other combinations of conditions. Another example here is, let's say we are asking for the age to be entered and the status of whether the person is a student or not. And based on that, let's say we are giving some discount. So we are saying that if age is less than 18 and the status is a student, both the conditions are true, then you mention that we will give you a discount. Else, we'll say that regular price applies. In this case, what do? We pass input as 25. So this condition itself has become false. Age is not less than 18. Status as a student is true, but and requires both the conditions to be true. So obviously, the regular price applies will be printed. On the other hand, if you would have changed the age to, let's say, 17 and the student status was true, it would have printed, you get a discount. Please note in Python, and as we type it here is a logical operator. When we write ampersand or a pipe operator, those are different operators. Those are bitwise operators. There's a difference between them. But for now, we are only talking about logical operators. So that's what we'll focus on. We can use multiple if statements. So far we showed you just one if, elif, and else. But let's say we have a grade thing and we have 4 or 5 levels of grades. So if the grade is greater than or equal to 90, we are saying it's a grade A. If the grade is greater than or equal to 80, but up to 90, and 90 in this case would not be inclusive because we've already included 90 in the if condition. Remember, all these if-elifs have to be mutually exclusive. So it can't be that 90 is accommodated here in the elif condition and in the if condition both. So when you're saying greater than or equal to 80, in a way, it is to be read like this, that this includes 80, but does not include 90. So the notation for this would be parenthesis like this, a round parenthesis, a round bracket versus a square bracket, which indicates inclusion. This is what it is supposed to be read like. So we are entering a grade value and we have a hierarchy of grades here. So we have greater than or equal to 90, greater than or equal to 80, up to 90, greater than or equal to 70 and up to 80, greater than or equal to 60, up to 70. And if none of these, then we are printing the grade as fail. So if we give the input, it'll find out the appropriate grade accordingly. Let's say we gave the input as 70. 70, as you can see, is included here. So it prints that the grade is grade C. Let's say we print the input as 90. What do you think it'll print? It'll print grade A. It didn't print grade B because B does not include 90. There's another way to write if-else in a single line, and it's written in the general syntax like this. So we check for if condition, and if condition is true, then we return the output like this. Otherwise, we execute the else block. So let's say we check if a given number is divisible by 2. If it's so, it would lead to a remainder of 0. And if that's the case, then the number is supposed to be even. It's written in a slightly different way. So if the condition is true, you write the if block. If the condition is not true, then you go to else and execute the else block. That's how it is, right? The advantage here is that this returns you an output. So earlier, if else, we were able to print things, we were able to do things, but we were not really returning a variable. But this single line execution or ternary operator use actually allows us to return a value. For example, here we can return a value, store it as a result and use it elsewhere, or even just print it right now, the way we are doing it. So this is a slight difference. Maybe this is a little unusual syntax for the beginners, but it's again something which has its own advantages at times. So let's say if we enter the value 10, of course, we expect that it will return the outcome as even. If we enter the value as something which is different, let's say 9, of course, it will return the output as odd. Pretty much working like the single combination of if-else, but it's a single line if-else as we call it. Now, notice that we don't write elif like this here. We can only write it for if-else. So this has a limited usage in that sense. So I hope this gives you clarity on the decision control if-elif. You'll see frequent usage of this within functions. A lot of times while dealing with data, we'll apply different conditions and filters on the data, and we'll be checking these conditions again and again. We may also want to modify our existing data using some conditions, and if-else, if-elif-else comes quite handy there. Hope this helps. Thank you.